All right, I'm going to take a look at one of these guys working with sine. Okay, so I might want to refresh my memory, okay, what the graph looks like. Remember, that guy's going to do this, okay, he's going to do this, okay. All right, let's see, we're going from 1 to -1. Okay, all right, so let's see what's going on here. All right, at x equals 0, well, we know at 0, we know the sign is 0. Okay, so we are definitely going through, okay, the origin there. Okay, and so we say, all right, let's do limit as h approaches 0 of the sine of x plus h, so that would be 0 plus h, minus the sine of x, which is 0, all over h. Okay, and we say, okay, well, let's, once again, we're not worried about taking a limit now, we're just going to take this guy and simplify it. Okay, so 0 plus h is just h, so I get the sine of h minus sine of 0 we know is 0, okay, all over h. So we're just getting the sine of h over h. We did something very similar to this. Okay, sine of h over h. Okay, now remember, and you can pull this out of your notes, we did this. The limit as x goes to 0 of the sine of x over x. And we went trial and error. We figured that out. That's 1. Okay, so this guy is 1. So it looks like the slope of the tangent line, okay, is 0. I'm sorry, is 1. My fault, 1, not 0. Okay, so our slope is 1. Okay, and so our equation, well, let's see. We would get y minus y sub 1 equals the slope times the quantity of x minus x sub 1. And we're using a slope of 1, and we're using 0, 0. Okay, so this becomes 0, that becomes 0, and that's 1. So we just get y equal x. Okay. Okay, so we got a slope of 1, and we get the equation of the tangent line through the origin of sine of x, and we get y equal x. Okay, I like that guy. Okay. All right, let's change this guy. Say this is happening at pi over 2. Okay. So again, let's remind ourselves what's going on here. Okay, we've got okay, right there. And we've got our 0. And remember, pi over 2 is right here. Okay, 1, -1. Okay, so it looks like we're right here, okay, at pi over 2 and 1. And boy, it looks like the tangent line might end up being a horizontal line. Okay, so we're working at pi over 2 and 1. Okay, so clearly if our tangent line is a horizontal line, we know we're going to get a slope of the tangent line is 0. So let's see what happens here. Okay. All right, so we got the limit as h goes to 0, okay, of f of x plus h, okay, so that would be sine of x plus h, and x is pi over 2 plus h, minus f of x, so that'd be the sine of x, or the sine of pi over 2, all over h. Okay. So again, I'm just going to deal with this guy, okay? And this dude's going to help out, okay? And I'm going to come back to that in a second. So we say, okay, I've got the sine of pi over 2 plus h minus the sine of pi over 2. We know the sine of pi over 2 is 1 all over h. Okay, and notice I have the sine of a sum, and I know we have sum difference identities. Okay, and let's see, here it is right here. Okay, the sine of a sum, so it'd be sine of the first times cosine of the second plus cosine of the first times sine of the second. Okay, so let's see, this guy right here would be the sine of the first, which is pi over 2, times cosine of the second, which is h, plus cosine of the first, cosine of pi over 2, times sine of the second, which is sine of h. Okay, and then we have minus 1 over h. Okay, so let's see. Well, the sine of pi over 2 is 1. So this is 1 times cosine of h plus cosine of pi over 2, that's 0. So that'd be 0 times sine of h minus 1 all over h. So this guy goes away. And so we end up with the cosine of h minus 1 all over h. Okay, so I've got to take the limit as h goes to 0 of this guy. So we go to the limit as h goes to 0 of the cosine of h minus 1 all over h. Okay, and so clearly if you just go in there, okay, cosine of 0 is 1, so you get 1 minus 1, which obviously is 0, and then 0 down here, so we get a problem. So why not do a little trial and error? Okay, let's choose values that are getting closer and closer and closer to 0. Okay, and so let's do 0.1, and then we'll do 0.01, and then we'll do 0.001, and then we'll do 0.0001. Okay, and then obviously I have to do this, cosine of h minus 1 over h. All right, now I'm going to use radians, and I'm going to start plugging that in there, okay, and see what happens. Okay, so let's see. Let me put it in radians. Okay, so I do the cosine of 0.1 minus 1, hit enter, and then divide by 0.1. I'm sorry. Okay, divide by 0.1. I hit 0.0. Okay, so it looks like we're getting negative point, and I'm rounding it off, about 0.05. Okay, let's go down here. Let's use 0.01. So I get the cosine of 0.01 minus 1, hit enter, and divide by 0.01. Okay, looks like I'm rounding off. I get negative 0.005. Okay, let's do 0.001. So the cosine of 0.001 minus 1, and then divide by 0.001. And I get negative 0.0005. Okay, let's do one more. So the cosine of 0.0001 minus 1, hit enter, and divide by 0.0001. And when I round off, it looks like I'm getting negative 0.12345. So notice what happens is this 5 just keeps getting further and further away from the decimal point. Okay, so if I keep going with this pattern, I'm just going to keep adding leading zeros, okay, which means that this is getting smaller and smaller, okay, and it's approaching 0. Okay, so the limit as h approaches 0 of the cosine of h minus 1 over h, we end up getting 0. Okay, so that means our slope is 0. Slope of the tangent line is 0. And when you think about it up here, it certainly looks like that is a horizontal tangent line. So if it's horizontal, it has a slope of 0. Okay, so I've got my slope, 0, and then I need the equation of a horizontal line that goes through this point. So that would just be y equals the y coordinate, y equal 1. And we're in good shape. Got everything we need.